Hey, welcome to the 8th lesson. In this lesson, we will learn how to work with dynamic memory and explore the usage of dynamic arrays in the C++ programming language. The C++ language was developed in an era when computers were not very powerful and memory management became a critical concern. C++ introduced the concept of dynamic memory, where you can allocate computer memory for a specific period. You can work with it, and later release, or in other words, free the memory. It's somewhat like renting memory for your purposes, temporarily. Why is this necessary? The reason is that computer RAM is not unlimited. Even in modern computers, it has its limitations. You can quickly fill it up by creating variables, arrays, and more complex structures and objects. To prevent this from happening, you need to manage memory. In C++, everything you create, variables, arrays, objects, takes up space in the computer's memory. This space is only freed up when the program terminates. Until that point, it is constantly occupied by your data. This led to the concept of dynamic memory in C++. In other words, you can allocate memory, store some value, and later, when you no longer need that data, you can free up that memory. To start, I suggest creating a simple variable. Let's imagine that this variable will be of type int, and let's call it number with a value of 10. Right now, I've created a regular variable, and its essence is that 4 bytes of RAM have been allocated for this variable. In reality, this is very little for modern computers, but the fact that some memory has been allocated for it is important. Currently, this RAM will only be freed when our program completes its execution. In other words, when the program reads through all the code and reaches this closing curly brace, that's when the memory will be cleared. This is the standard behavior when working with variables or arrays. So, we can create regular variables, arrays, or objects, and we can also create all these things considering dynamic memory. However, considering dynamic memory specifically in the context of working with variables is not particularly sensible because variables are so small that, in principle, they do not require any dynamic memory. In other words, 4 bytes, even for an old computer, is not a large amount of memory, and you can work with this variable without using dynamic memory. Therefore, typically, dynamic memory is not used for a regular variable like this. Now, let's consider dynamic memory in the context of arrays. To do this, let's first create an array, name it nums, and specify that this array will consist of 3 elements. It's important to understand that each element in the array is like a separate variable. So, our array currently occupies 12 bytes since it's of type int and consists of 3 elements. The size of our array is, therefore, 12 bytes. This is still not problematic for the computer. Now, imagine that our array has 30,000 elements. This is truly massive. Using dynamic memory becomes highly justified in this case. To allocate dynamic memory for our array, we need to do the following. As a keyword, we use new, which initiates the memory allocation process. Then, we specify what we are allocating memory for. In my case, I am allocating memory for an array consisting of 3 elements. Currently, our construction will give us an error because we need to make a slight change to the array we initially created. In fact, we should first create a pointer, not an array. To create a pointer, you simply place an asterisk before the variable or array name. Regarding pointers, we'll have a separate lesson on this topic because it's crucial in the C++ language. For now, let's just add the asterisk and understand that memory allocation works specifically with pointers. We'll delve into the concepts of references and pointers in a separate lesson. For now, let's not focus too much on this. So, what do we have now? Currently, we have allocated memory for 3 elements inside the pointer. Now I can do the following. I can simply refer to this nums as if it were an array, access an element at index 0, for example, and set any value. Also, let me print this element to the screen and try running it. you'll notice that everything will be processed just like working with regular arrays. The only difference now is that we have a dynamic array. By using the new keyword, we allocated memory, and at the moment, this memory is still occupied. We are not clearing the memory anywhere, so it will be automatically cleared when the program finishes. This is not entirely correct. The thing is, if you allocate memory somewhere, you must manually free it. So, let's add this aspect as well. In general, you need to free up memory only when you no longer need it. So, I utilized the memory here, assigned a value to an element, printed it to the screen, and essentially, I don't need this array anymore, it has served its purpose. Therefore, at this point, I should free up the memory. Memory must be freed, it's crucial. Before this, the program worked, but without memory cleanup, the computer's RAM could quickly fill up, causing the program to stop working. So, don't forget to address this aspect. To clear the memory, it's sufficient to write the word delete, and then specify what exactly we are deleting. In my case, I'm deleting nums. Since nums is an array, after the word delete, you need to add square brackets. If we were deleting a regular variable, square brackets wouldn't be necessary. Now, if I run the program, you won't notice any difference, and everything works just the same. However, now you should understand that, when we allocate memory in the computer and work with it, we need to free it up later. The bonus here is that if you have many lines of code afterward, all those lines will occupy the entire memory space where the array was previously located. In the future, we'll continue to work with dynamic memory as it is very convenient. We essentially rent memory, work with it, and then, when we no longer need it, we simply free it up. Such memory allocation can be used for arrays as well as for objects, which we'll explore in the future. We'll delve into objects when working with various structures or classes, i.e., in the realm of object-oriented programming. For regular variables, dynamic memory allocation is typically not used because variables are small, and it's easy to manage without allocating memory. Well, that concludes our lesson. I hope you enjoyed it, and if so, don't forget to subscribe to the channel and give this video a like. That's it for me. Until next time, goodbye.